ब्लॉग में आप सभी का स्वागत है। नमस्कार, गुड इवनिंग, सत श्री अकाल, वणक्कम, जो जहाँ पर है सबको सलाम। आप सभी को पता है कि हमारे देश ने एक बहुत बड़ा एक माइलस्टोन अचीव किया है, जो कि चांद पर हमारा चंद्रयान लैंड किया कल शाम को करीबन 6:04 पर। चाँद चाँद को हम हमारे यहाँ मामा बोलते हैं और धरती को माता बोलते हैं, तो एक तरह से भाई बहन हुए धरती और चाँद। तो रक्षाबंधन 31 तारीख को है, उसके पहले ही चाँद ने धरती को रक्षाबंधन रक्षाबंधन भेज दिया, आपस में एक मिलाप हो गया। इसी बात को ख़त्म करते हुए मैं आज के हमारे जो गेस्ट हैं, द गेस्ट ऑफ टुडे, मिस्टर प्रकाश राव, वेलकम टू दिस शो।
नमस्कार सर।
Before we proceed further, I would also like to inform the audience about Mr. Prakash Rao. Mr. Prakash Rao is an outstanding scientist of Indian Space Research Organization. He was serving as the Director, Space Infrastructure Program Office at ISRO headquarters, Bangalore, just before retirement, reporting to the chairman ISRO directly. He also briefly held the additional charge of director. इफ आई हैव टू गो थ्रू द एंटायर, अगर मैं इनके पूरे बायोडाटा को पढ़ने जाऊंगा तो 10 मिनट उसी में लग जाएगा। इतना ही कहना चाहूंगा मैं कि ही हैज स्पेंट ऑलमोस्ट 40 इयर्स सर्विस टू द नेशन थ्रू इसरो। इसरो इन्होंने जिया है, इसरो इन्होंने सांस ली है, इसरो को ही ब्रीथ ब्रीथ किया है हर दिन, हर वक्त, हर समय। तो इसलिए इसरो इनकी जान है। तो आज इनसे बेहतर हमें कोई नहीं मिल सकता था चंद्रयान मिशन के बारे में बताने के लिए और स्पेस के बारे में इन जनरल बात करने के लिए। मैं ये भी बताना चाहूँगा कि मिस्टर प्रकाश राव सर्व्ड एज द प्रोजेक्ट डायरेक्टर GSAT-9, जिसके बारे में आप सभी लोगों ने सुना होगा। ही वाज आल्सो साउथ एशियन, ही आल्सो was the heading the GSAT-17 and GSAT-18 communication satellites, and also project director of GSAT-6 spacecraft, which had flown the 6 meter unfurlable antenna, the largest on-board antenna built by ISRO. He has also been, or he's also the fellow of Astronautical Society of India, a great honor for any scientist in his life. And he's still associated with, as the elder of ISRO, he's still associated with the ISRO in various capacity as advisor, as guiding light, etc. So, a very, very warm welcome to you. I am sure our audience are looking forward to interaction which we are going to have with you. Before we start, I would like to play a video just to commemorate this Chandrayaan 3 success. So, just hold on, audience. I will be playing this short video which captures the entire. What a fantastic visual that was. With that, we will now move on to the interaction proper. Sir, tell us about the importance of space exploration. हमें space explore क्यों करने की जरूरत पड़ी? इसके advantages क्या हैं? What are the pros and cons of space exploration? What spin-offs we get in general for the society? Over to you, sir. The floor is yours.
Namaskar, sir. General Dushyant Singh ji and all the brethren of army who assembled here, the veterans. पहले आप सबको मेरी तरफ से हृदयपूर्वक नमस्कार. Before I answer the question of General Sir, I would just like to be little emotional. Okay, I think you please excuse this transgression from a civilian. Okay,
नो
so
प्रॉब्लम सर,
before
नो
because it was my
प्रॉब्लम.
childhood desire.
मैं अपने
It
ऑडियंस को
was
ये बताना चाहता हूँ कि मिस्टर राव हैज अग्रीड टू गिव दिस टॉक इन हिंदी एंड इंग्लिश बोथ, सो दैट सभी को इसके बारे में पता चले. सर आगे बढ़िए सर.
हाँ, थैंक यू सर. सो इट वाज मेरे के बचपन से बहुत शौक था कि आर्मी आदमी बनना है बोल के. मैंने एनसीसी में ज्वाइन हुआ, मगर मेरा फिजिकल फिटनेस वाज सो पुअर, सो आई हैव टू चेंज द ट्रैक. बट व्हेनेवर आई सी any army colors, my hair gets raised. Okay, and actually I never dreamt even in my wildest dreams that I will be entering the very pristine premises of Army War College. Actually, it's at the invitation of General Dushyant Singh Ji that I have gone there and could deliver a lecture in the presence of soldiers general. I am sure every soldier has a tremendous respect for General Bipin Rawat ji, and I delivered a lecture in front of him and received a memento from him. For me, that is the highest point of my career as far as I am concerned. That is because of the tremendous respect I have got for all the community of Indian armed forces. So, with this small transgression, sir, I will come back to your question. You are
यस,
asking about why we have to take the space. What is the
यस,
special advantages of space? Why you
करेक्ट,
have to explore from space when things
यस,
can be done on from the ground? Of course,
करेक्ट.
by space, what we are doing is actually we are going to higher heights. So I think for a Fauji persons, I need not tell the advantage of going to heights, because we spend most of our resources in protecting our heights, the Kargil
Yes,
being the best example of that, because it provides a large coverage area. Even from the oldest times, if we take the watchtowers, the lighthouse, even in the film Bahubali, when he wants to destroy a large army, he goes to a height and some kind of cloth with, so that they will put. So this is the greatest advantage to get a wider coverage, and then obstacle free, okay, observations, and unaffected by natural disasters. Whatever happens, let it be a flood, an earthquake, or anything, if you want to survey the situation on the ground, the space provides a very good vantage. And of course, we can, no need for any James Bonds and all, without entering to the territory of the enemy space, we can still monitor across the globe what is happening. So that is
करेक्ट.
another advantage, and security also. See, on ground, the assets are always vulnerable to attack, whereas in space, it's very, very difficult to attack a resource which is situated in space. Of course, there are methods, but it cannot be done by any person or an individual or a small organization. It needs a nation. That will not be anyway happening normally, because difference is always there. And repeativity and flexibility, if you want to keep on repeating the measurements, aerial means are regular helicopter or aircraft survey and all, they will not be adequate. So that is where the repeativity, all these things will come. Of course, every
Mr. Rao, Mr. Rao, I
yeah,
would like to just interfere here to
yes sir,
explain the importance of the last point which you gave. इस पॉइंट की कितनी कितनी अहमियत है रिपीटेटिविटी, रिपीटेटिव
yes,
जो एक्शन होता है. जैसे कि आप मान लीजिए हमारा एक सोल्जर है, बॉर्डर पे रहता है, रोज उसी टाइम पर ड्यूटी पे जाता है, तो
correct,
किसी दिन उसकी आंख लग जाती है, उस दिन उसके ऊपर हमला भी हो जाता है. लेकिन
correct,
सैटेलाइट में ये गुंजाइश नहीं है. वो हर समय उस चीज को देखता रहेगा बिना फॉल्ट के, बिना फ्लॉ के. तो ये एक बहुत बड़ी एडवांटेज है फॉर द
yes,
डिफेंस पीपल आल्सो, स्पेशली जो सर्वेलेंस सैटेलाइट्स हैं. राइट सर, गो
yes sir.
अहेड.
Thank you, sir. I just want to little more expand on this point. If you want to constantly see the same point, we have to be in the geosynchronous orbit, which is at 36,000 kilometers height. But from that kind of height, the resolution will not be as good as we want. So we will be doing from a lower Earth orbits, which are around 500-600 kilometers. So there, what happens? The satellite will be trotting around the globe. But that is where, by having a constellation of satellites, say certain number of satellites in different phases, our observation power increases, and we can always go back also. Some new algorithms we have introduced by which you can go back and see what you have seen yesterday. So with this kind of techniques, yes sir, whatever you have said can be correctly done. But of course, every advantage comes with some trade-off will be there. That is
Yes.
because as you go to higher height, there will be a lesser clarity. The
Mm.
resolution will suffer, and signal. Along with signal, there will be a lot of unwanted also, because you want to see a specific thing, but there may be so much of environmental effects. Space as such is unforgiving environment, so that is another thing which we have to account for. So naturally, all this makes it very costlier missions that may look costly for a single spacecraft. But when you see the capability of the spacecraft over, say, 5 years, or communication spacecrafts which work for 15 years, and multiply the kind of same thing if you want to do through ground, and some of them is not possible by ground at all, especially if you want to observe a place where we have no access. This is the only means. So that is all makes the space systems very attractive. Thank you, sir.
So we now come to the most important issue of today's discussion. आज का जो सबसे जरूरी discussion ये
Yes,
था. Now we have understood that why space is required and
yes,
why space के technologies are required both civil के लिए और defense के लिए.
yes,
So what is the next question is, why is space mission so challenging? Can you explain with reference to Chandrayaan
yeah,
mission? Chandrayaan mission जैसा कि people know that it had three sequels: Chandrayaan 1, Chandrayaan 2, and then finally Chandrayaan 3. Chandrayaan 2, due to some reasons, could not succeed, but it gave us a lot of lessons, and therefore we had the success in Chandrayaan 3. So, could you
yes,
explain this entire process where the success rate is very low, 50 to
yes,
60%? कुछ दिन पहले ही हमारे रशियन जो जो पहले ही इसको कर चुके हैं,
yeah,
their mission failed. We
correct,
are not we are not trying to say that there was some anything wrong with that
yeah,
mission. We just say that the probability of failure is very high, and
very
even developed nations can see failures. तो हमारे लिए एक बहुत बड़ी achievement है. Just elaborate on Chandrayaan mission
high.
and its challenges.
Yeah. So once again, before explaining challenges, I also would like to join the whole of India in complimenting the Chandrayaan team, because and उनको अपनी सब लोगों की तरफ से बहुत बहुत बधाई है. And I will tell now why the space system becomes challenging, because it is an unattended operation. Some communication spacecrafts, if we take, they work for 15 to 20 years of life without being attended to. So, in any system that we use on the ground, it needs frequent maintenance and all. Here, you have to make the systems maintenance free for 15 years, and they are not ordinary systems. Some of the wheels and all which they run with something like 68 Newton meter second kind of torque they will be generating. They have to
Oh,
work for 15 years without interruption, and they will be running at 5,000 rotations per minute.
wow.
5,000 rotations per minute for 15 years. So these
Mm.
kind of systems are there, and of course electronics, all the systems. But I am giving one typical example where there will be a lot of issues, and
Yes.
it's a multidisciplinary product. Any branch of engineering, management, science, anything you name, that will find a place in spacecraft and launch vehicle engineering. And the work environment of space, that is another very, very challenging thing, because you have zero G, there is no gravity, or microgravity is there, and vacuum is there. So it poses its own challenges in designs of systems, and extreme temperatures. On whenever sun is seen, is that solar panels can go to plus 100 above temperatures. When sun is not there and it is in eclipse, it can go to minus 100 degrees centigrade. So how
Okay.
do your systems design to space itself? If you take deep space, it is 4 degree Kelvin, that is minus 269 degrees centigrade. So that is
Wow.
the deep space temperature. So we have to build systems to insulate from
Withstand.
that and withstand. And of course,
Yes.
volume, mass, and power constraints. Because the launch vehicle volume is limited, you have to fit the whole spacecraft within the available volume. At the top, whatever we see, Indian flag. So within that volume, we have to fit the spacecraft, and a weight also. Whatever Bahubali or whatever it is, still it has got a limitation beyond 3.5 tons or beyond 4 tons. Even the
Correct.
world's largest SpaceX itself, you take their rockets also, they also have a cap. So how do you get maximum utilization doing all the maintenance functions plus get the best out of the payload? So this is
Uh,
what makes space system challenging. Now I
Mr.
will talk about the Chandrayaan, which you were
Yeah.
telling, and so why moon
So
landing mission
before,
is challenging. Here also I would
yeah.
like to just give a clarification, sir. Though Chandrayaan 2, we have not succeeded in the goal of landing, the camera which is there in the Chandrayaan 2 orbiter today, that is the best in the world class. All over
Wow.
the world, the countries, they look for Indian maps. Okay, whatever moon atlas is made by our OHRC, optical high resolution camera, that is
Mhm.
saying with a 25 centimeter resolution it has mapped the moon. So today any country, if they want to get a very good clarity, they seek help. Actually, contrary to what is there in media, all spacefaring nations, they cooperate with each other, including US and Russia. It's global. We will talk all that Cold War, those times are over. Even till
Mm.
recently, before Elon Musk, the launches for all American astronauts were carried by Russian vehicles. Of course, at a price. They may be paying
Yeah.
$250 million for each astronaut, but the cooperation was there. So here,
Miss-
moon landing, why it becomes challenging is moon is at an average distance of 384,400 kilometers from Earth. So how do you have to need tremendous energy to reach there. The means could be different. We do it in different way because of the capability of our launch vehicle. And then one translunar injection, whatever was so much talked about in media, I will not be. But there the criticality is if you get little more delta V, we call velocity increment than what is targeted, you may miss the moon and it may become a flyby mission. If you give little lesser velocity, then the fuel optimization will come down, your mission targets may suffer. And if you are not able to give full increment, it may even crash also. So that is another
Mr.
challenge.
Mr.
And
Rao,
there is,
Mr.
yes,
Rao,
sir.
if you could tell our people who are, not that highly technically qualified,
Yes,
the
yes, sir.
challenge this particular slide also, because this you made it yourself, कि
Yes,
how कितना difficult है कि कितने लोगों ने लॉन्च किया और कितने सक्सेस हुए हैं, कितनी बार हुआ है. दिस विल
yeah.
एक्चुअली उनके दिमाग में डालेगा कि ये कितना बड़ा अचीवमेंट है.
Yes, sir. Sir, here the actually, if you see, there are different types of moon missions. One is orbiting, which now Chandrayaan 2 also is doing, going around the moon. Actually, utility wise, if you see, that is the most productive thing because you are continuously circling around the Earth on the object or the planet, and you are getting continuously different images and you are able to cover the whole thing. So, that is the beauty of the orbiter missions. Then there is a question of flyby. So they actually originally when they were doing, when they cannot circle all those things, they were just passing through and take some pictures. That is to initial technology demonstrations. Then
Right.
the lander things will come, and also of course uh, the robotic missions. There are some robotic missions which you can go there, dig it, and bring back the sample. Okay, sample return mission is another thing. Okay, and of course the ultimate pinnacle of all these things is the manned missions. So far in the world, the manned missions are done only by America. They have sent some 14 astronauts or so in 6 or 8 missions to the moon. And the landing missions themselves are accomplished only by 3 countries till yesterday. Okay, yesterday we became the fourth country to become
Fourth
that
one.
landing. And some people attempted whatever you are seeing in oranges. Okay,
Yeah.
Japan, Israel, and even Luxembourg, I think. So they have done some things and they have attempted and not succeeded fully, which is nominally expected in the first missions. And of course, China is there who have done a good bit portion of that. So
Has
now,
has China done more than one lunar landing mission, or they have
yes,
done
two
only one?
landings they have done, and they have also done sample return mission where around
Okay.
1.7 kg of lunar samples they have brought
Hmm.
it back also. It was a robotic mission. They dug the earth and they brought back.
Okay.
So so now coming back to the challenges, there is no atmosphere on moon. So you want to land on Earth, like so many, even Elon Musk things you would have seen when they want to come back, or even manned missions and all, they come down with the help of a parachute. So that helps a lot. On moon, there is no atmosphere. When there is no atmosphere, you have to depend on engine power to overcome the effect of gravity. Whatever engines we are seeing as firing, what they are doing effectively, they are overcoming. Normal rocket, what happens? It goes with such a kind of acceleration that it overcomes the gravity and goes away from the Earth's influence. Rocket, when you are seeing. But when a landing mission, what happens? Engines are still fired in the same way, but they are controlled and in such a way that otherwise, due to gravity, it would have fallen down. Now you are reducing थोड़ा थोड़ा कम करके वेलोसिटी को, इंजन पावर को थोड़ा थोड़ा कम करके. बट इसको ऐसा करना टेक्निकली it is a very challenging job. There are something called throttleable engines. So the
Mm-hmm.
development, demonstration, that is another very, very difficult portion. And of course, command data reception, these are all communication systems. So इतना दूर 4 लाख किलोमीटर तक आप कैसा कम्युनिकेट करोगे? सिग्नल लेवल बहुत कम होगा. इसीलिए आप देखा तो वर्ल्ड वाइड ऑल्सो whole we again network of stations are supporting Chandryan 3 across the globe. So there are very huge antennas. We also have a 32-meter dish antenna which can detect बहुत कम signal को भी पकड़ के वो process कर सकता है. But in that again you have to eliminate the noise and do, for which technologies you have to develop. And testing and design for harsh lunar environment is another challenging thing. And land site selection itself, because at least when we want to do, as we get more and more confidence, we can take up more and more challenges. Actually, a recent Japanese mission, whatever they failed, they changed towards end the landing site selection. They wanted to explore more, and they selected some area where craters are there. So that for that they have not tested. For that environment, they have not tested. That's why they have failed in the last few kilometers. So that is what will happen. So this testing for the environment, landing site selection, and the legs on which you are landing, you can make it very sturdy by going with some very heavy structures. But here the weight is a limitation. If you want to increase, so how do you make a low weight but high strength landing legs, which can, and shock it has to absorb, landing velocity, all those aspects also. Landing leg design also is a very challenging aspect. And of course, trade-off between fuel and the payloads, what you want to get the science from it. Finally, we are going for doing some experiments. So what is the trade-off between the fuel that you can carry? And this is another most important part, is the highly accurate sensors. Because as all of you would have seen, जो आपने देखा होगा, वो पिछली लास्ट वो आधा घंटा जो भी है 20 to 20 to 30 minutes, वो पूरा खुद अपने आप को करना करेगा. So कैसा करेगा? The sensor suit, whatever is there, electro-optical systems, it's an extremely, because बनाना तो कर सकते हैं, but उसको calibrate करके sometimes in that fault tolerant features build जो करना है, वो बहुत मुश्किल काम है. और उसको टेस्ट करके वो algorithms वो सबको validate करना also is an extremely challenging job. And actually some agencies, they spend last part of 8 months to 1 year in just calibrating those sensors. So that is another thing. And guidance and navigation. कल जो बोला था, आप इतना दूर से इतना ज़्यादा वेलोसिटी है, उसको कम करते 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 जो स्पेसिफिक लैंडिंग साइट प्री प्रोग्राम्ड है, वो ऑलरेडी इट इज़ देयर इन द सिस्टम. सो वहाँ तक जाके आप कैसा पहुँचेंगे? सो फॉर दैट देर आर सो मेनी मैथमेटिकल मॉडल्स, देर आर algorithms which have to be developed. That becomes a very, very challenging. This is where we take even reviewed by other academics also, some top academic institutions also, all that is done. Then error-proof software. Actually, software everybody feels is very easy, but we know how it can give glitches. So the software development and testing and validation for, we call 6 sigma, 3 sigma dispersion cases. Suppose an engine is supposed to give certain amount of thrust, or a sensor is supposed to give velocity. That velocity it is supposed to give within say 1 meter per second. वो 1 मीटर के बदले 1.1 मीटर पर सेकेंड हुआ एक्यूरेसी, तो क्या होगा? ये इंजन इंस्टेड ऑफ से 800 न्यूटन्स, इफ इट हैज गिवन 750 न्यूटन्स, तो क्या होगा? All these scenarios have to be built into the algorithms and they have to be validated. That is also a very. So then mission planning, as you have seen, everything happens to the clockwork precision. I am sure our military drills also are like that, but here they have to do it in the, there it may be minutes of or seconds. Here it could be to the accuracy of milliseconds and all. You have to plan because things are moving at such a high speed and there are constantly orbital positions of sun, moon, earth are constantly evolving. So these kind of orbital dynamics, it has to be understood and done. Then power generation pointing towards Earth with a specified accuracy for communication. Then rover. This was less spoken till yesterday, only landing portion, but now everybody is seeing what rover can do. So that
Correct.
rover design because lunar soil. It is not
रोवर
like a
रोवर भी एक तरह का रोबोटिक ही है, आई मीन इट्स लाइक
Yes, sir.
रोबोटिक
It is
रोबोटिक.
full of mechanisms. It is full of mechanisms. It's a kind of robotic only, mostly consisting of lot of mechanisms. ये एक गाड़ी है. आप सोचिए एक गाड़ी which is working with the commands from the lander. Lander is giving the commands and it is going around and it will be going around half kilometer around the lander. So for that also it is there path refining. So this laws are I was telling about the lunar soil जो है वो जो धरती को वो चंद्रमा का धरती को वहां पर हमें लाना पड़ेगा. सो उसको भी लकीली दे फाउंड ए one area in Tamil Nadu at some place, the sand is having the characteristics of lunar soil because you
वाह.
have to simulate that kind of traction and what is the kind of resistance that it faces. If you do it for the earth kind of conditions, it may not work there. It may get stuck or it may roll out. So anything can happen. So those simulations and all are also challenging points. And of course, project management. Any mission of this kind over so many years, how do you keep the spirit of all the people? That too, after a failure, how do you come back? So that is where complete discipline of project management, then functional quality, budget, schedules, because all this said and done, there are always constraints. It's not that you get whatever money we want. All over the world, even NASA faces budget crunch. So within the available resources, how do we manage? So all these aspects put together will make the landing mission very challenging. And I'm really happy that the team Chandrayaan has done it. And once again, I appreciate all of them for pulling out a success out of such a difficult mission.
मिस्टर राव, बिफोर वी गो अहेड, मेरे दो छोटे से सवाल हैं आपसे. जैसा कि
Yes.
आपने बोला कि चैलेंजेस बहुत थे, एक फेलियर भी हुआ. उस फेलियर के बाद हमने देखा कि इसरो चेयरमैन काफी
Yeah.
दिख रहे थे ना, एक तरह
Emotional
से
हुए थे. ठीक है.
इमोशनल
Yeah.
हो गए थे कि वो सक्सेस नहीं मिली. और इस बार भी वो बैठे हुए थे लॉन्च के टाइम पर, जब
Yes.
करंट इसरो चेयरमैन अपनी स्टेशन
Yeah.
पर थे और ये गेस्ट उसमें थे. और उन्होंने भी काफी इमोशनली बाद में एक स्टेटमेंट भी दिया. तो एक लीडरशिप चैलेंज बहुत बड़ा होता है. तो खाली मेरे ख्याल से मिलिट्री में नहीं लीडरशिप, बल्कि आपकी ऑर्गेनाइजेशन में भी एक लीडरशिप का बहुत बड़ा रोल है. तो कुछ आप इसके बारे में कोई किस्सा बता सकते हैं जो अ, किस तरह से आप लोगों ने ट्रांजिशन किया फ्रॉम अ फेलियर, आई वोंट से फेलियर, और फ्रॉम अ पार्शियल सक्सेस टू सक्सेस, एंड आपकी लीडरशिप का क्या इसमें रोल था? मैं इसरो की लीडरशिप की बात कर रहा हूँ. और
Yes.
दूसरा कि इसमें इंडिजिनस कंटेंट हमारे इस पूरे मिशन में कितना है, ओनली इन टर्म्स ऑफ लेमैन के लिए कितने परसेंटेज, ज्यादा डिटेल
Yeah.
में जाने की जरूरत नहीं है, बट इन दो चीजों पे अगर आप थोड़ा सा अपना वो लाइट डालेंगे तो इट विल बी वेरी गुड.
ओके सर. सर पहले जो भी हम करते हैं काम, पहले से ऐसा स्पिरिट बना हुआ रहता है कि मुसीबतों को देखकर मुस्कुराना और मृत्यु को देखकर उछलना. सेकेंड पार्ट में भी एप्लीकेबल टू आर्मी. ओके. और आर्म्ड फोर्सेस. सो मृत्यु को देखकर उछलना यवन का शील है. आई थिंक दिस स्पिरिट इज देयर इन ऑल द पीपल वर्किंग एट
क्या
इसरो
खूब,
एंड इवन.
क्या
यस सर.
खूब, लाइक मैंने क्या क्या
थैंक यू
बढ़िया
सर.
बोला आपने. एक
हाँ
एक
बड़े समझ में आया
एक,
सर. ठीक है.
एक
थैंक यू.
सोल्जर की तरह
सो
आपने बात की.
so this is there built into the uh, whatever adrenaline or whatever genes of gene may be from birth, but the moment we enter ISRO, it is like taking a rebirth. The whole organizational culture is so absorbing and it is so inspiring. You never, on the day of failure, people will never go home also. They sit and try to see what went wrong. And even after success, yesterday whole country was celebrating. Maybe after that initial half an hour of TV coverage, all the scientists were working whole of the night to make rover operational. So neither by success nor by failure we are not so much deterred. Of course, everybody is happy at the success moment. That is okay. But otherwise, it is built into the steel nerves. Whatever you are having, similar nerves are required, and that comes once you join ISRO. I think there is, because it is a पीढ़ी है ये. जब इतना परंपरा से ऐसा आ गया है, right from the days of Professor Vikram Sarabhai to the current chairman Somnath, every leader inculcates. There is no special coaching or training, but you are always seeing leaders of this kind around. And one more is, when a failure is there, you are never admonished. Okay. So people immediately, we try to think what went wrong rather than who did the wrong thing. Okay. So
Yes.
idea is not on pointing a finger at somebody, but to collectively, because success is also collective, failure is also a collective responsibility. So we try to see, and we have got a very strong review system. Yesterday chairman also was mentioning, where even retired or very veterans of ISRO, they also help in the process. So all these things make it together the required courage to face, and from the next hour onwards, people will start working for the next mission, irrespective of whether it is success or failure.
So indigenous content के बारे में कुछ बताएं, कितना है तकरीबन 75 80,
Sir,
but
it's
I mean just
almost, especially Chandrayaan, if you take, it is
हाँ हाँ
almost everything is indigenous. Okay.
वाह,
So
ये एक
all
बहुत
the
बड़ी
mechanical systems,
एक
yes.
एक बहुत बड़ी न्यूज़ जो हमारे
Yeah.
व्यूअर्स के लिए वो है
Yes.
कि
Yes.
इंडिजिनाइजेशन इस फील्ड में तकरीबन तकरीबन
Yes.
100% है, एक आध
except
कुछ
for except for the electronic components, VLSI devices. That also our SCL Semiconductor Limited in Chandigarh. They are also making some of the very high level, but general electronics devices and all. Because not that we cannot do, but the market should be there too, and that also efforts are being done now by MITI to enhance and have the indigenous foundries where we can do commercial production of the integrated circuits and all. But for that segment, if you take even detectors, which are the most difficult component, ISRO, earlier SEL was part of it, now it is in MITI, but they have done development of many detectors, which in the whole world there may be one person or one company may be doing it. So those kind of detector development also has been taken up by for all these missions, not only Chandrayaan and several of our reconnaissance
so now
satellites, optical
so now
payloads.
so now so now that you have explained the challenges and more or less the entire Chandrayaan
Yes,
issue, just very
yes,
briefly talk about Chandrayaan 1. What was the role and what did we achieve? Chandrayaan 2, what was the role? What did we achieve? Rather than going through the whole process and then
yes.
hit on to Chandrayaan 3.
Okay, sir. So Chandrayaan 1, that time the objective was only to launch and have an orbiter. First, we have to establish the whole process of going around the moon. So those
Okay.
mission has to be achieved. So whether we can do it or not, we have to understand ourselves. So it was
Mhm.
having only orbiter that time, because you have to go step by step. So that was done, and it has done map to the moon, okay, using in infrared, visible, and X-ray bands, using some 11 scientific instruments. And another speciality of Chandrayaan was, internationally people have contributed. Apart from ISRO, NASA, ESA, UK, Sweden, Germany, Bulgaria, they all have put their payloads, because they are getting an opportunity to experiment on the moon, and India also has provided them an opportunity. So it was a very internationally joint effort, like as far as payloads are concerned. Otherwise, orbiter, the launch, everything is indigenous, except for some of the instruments they wanted to put, and India, in a good spirit of international cooperation, has offered to give them. And data received from MIP, that Moon Impact Probe, this was introduced by, actually last this one based on suggestion from then President Dr. Abdul Kalam. So that has confirmed the presence of traces of water. It was never the objective, but it so
Okay.
happened that because he wanted to have so इतना कर रहे हैं तो कुछ तो अपना presence दिखाना है. So you go and
Mhm.
so that was the idea, but it was a discovery which happened, and which has really opened up the floodgates of further research on that. Then in Chandrayaan 2, originally we wanted to do with Russia, but due to some other reasons that did not happen. But opportunity, adversity is the opportunity. So we have
Good.
developed our own instruments, and the instruments of Chandrayaan 2 at that time were diverted to Mangalyaan mission, and that also has been very beautifully. First time itself we have accomplished that mission. Actually, Chandrayaan 1 also, in the first attempt itself, we could successfully orbit around the moon. And as I have already told you, Chandrayaan 2 has got a lot of experiments, and in several bands it is doing, and the most significant one being the OHRC, which is the best camera of the world. So, and orbiter is still working. That is the reason why in Chandrayaan 3 we had the luxury of not having an orbiter, because it will work for another few years. So why to
Okay.
waste resources on that, and put those resources to increase the robustness of Chandrayaan 3, because our total weight is limited. You can go only with this much of a weight. So how do you go about? So that is thing, and it may be general of interest to know that Americans have got a LRO, Lunar Reconnaissance Orbiter. At once there was a probability. Okay, it's not that they will, but there was a chance that we may hit each other. So at that time
Oh,
we did a maneuver also to avoid
okay.
that in-orbit collision. This will be done in close coordination with whichever object is likely to see. Then we
Okay.
will go to Chandrayaan 3. Anyway, I think so much the TV coverage was there. The media houses now actually very much common people also, they are able to explain some of the mission phases of Chandrayaan. Sometimes I feel even better than me. Okay. So that is the kind of awareness which I think in this particular case, definitely we have to appreciate our media also. They brought a
I'll
lot of
I'll
technical.
I'll request you to just say that what went wrong in Chandrayaan 2 and how did we correct it. That's all. Rest the
Okay.
public knows since yesterday they have been listening to it
Yes.
in a
Yes.
layman's term कि क्या
Yes.
कहाँ गड़बड़ हुई थी और बाद में उसको कैसे वो
ठीक है सर,
इसमें कैसे ठीक
चंद्रयान,
कर दी.
ठीक है सर, चंद्रयान 2, I am quoting from the parliament statement whatever our honorable minister has stated. So some of the
Mhm.
engines, okay, which were supposed to bring in the particular phase of that rough braking to fine braking whatever you have seen, वो आने में वो थोड़ा जरूरत से ज्यादा फायर हो गया. ठीक है.
Okay. Okay.
Recently Russia also, when they have lost, it is not in the final this one, but in their overall thing they also have got more velocity than where they wanted. But in
Right.
general we design for those kind of dispersions. But ये
Mhm.
थोड़ा और ही ज्यादा हो गया, वो फायरिंग थोड़ा ज्यादा हुआ. Because of that some errors have developed. And
Okay.
add to that, in general, many space missions over the world, if you see analysis, what happens is they, it's not just due to one reason. Oh, at that time, like Lord Karna's death, they say, oh, he has died due to some 6 or 7 reasons, because of Kunti or this one, and Vasuki has asked some, this one, Vasuki, Arjuna has asked, some Indra has Naga, everybody has a Nagastra will not work at the time. Like that, some several combinations will happen when we are unfortunate. I think here at that time we had a software glitch also, so which
Mhm.
has aggravated. Had that problem not happened, this software glitch would not have been known also. Actually, we would not have been knowing there is a problem also. But here,
Oh.
because the environment which the software was tested was exceeded, and unfortunately, in that area only, there was a glitch in the software. So the
Okay.
combination of this and a few more small things has led to the Chandrayaan 2 failure. But again, opportunity, any adversity is an opportunity. So
बिल्कुल
ISRO,
बिल्कुल.
what we do is whenever a failure comes, you don't restrict yourself to analyze what went wrong and correct only that area. We take it as an opportunity and see all the systems. Till the time it failed, you may not be seeing failure, but all the systems, whether they have worked up till the point to the perfection, they might have worked, but have they worked to their specification or whatever we originally wanted, all that part will be analyzed, and where is the scope for improvement, all that also will be seen. Based on that, several improvements are carried out in Chandrayaan 3, right from the selection of landing site, where we went to zero point 0.5 kilometers by 0.5 kilometers. From there, we went to 4 kilometers by 0.25 kilometers. So that is the type of thing which we have done. And of course, then the guidance algorithms also, they were not just restricted to one site. In case of failure, you can switch to alternate site, and if both of them are not happening also, you can land wherever you are after ascertaining the safety. So that is called salvage guidance or emergency procedures. Those things are also were incorporated. Apart from that,
So
the landing leg, yeah.
so the I mean basically Chandrayaan 2 Chandrayaan 3 corrected all these things and we had a success.
Yes.
तो अभी
Yes.
बातचीत चल रही है कि एक रोवर जो है खाली 14 दिन काम करेगा लैंडर और रोवर
Yeah.
और 14 दिन के
Correct.
बाद वो तो
Yes.
14 दिन में क्या काम करेगा थोड़ा सा जल्दी से और खाली
Yeah.
14 दिन ही क्यों अगर
Yeah.
ज्यादा करना है तो व्हाई हाउ इट कैन बी डन.
Okay. Sir, okay. Now you asked about 14 दिन. First, what it will do? वो
मुझे
ये
तो
करेगा कि लैंडर
ऐसा
के
लगा
ऊपर थोड़ा इंस्ट्रूमेंट्स है. In lander
मुझे
we have
ऐसा
got some instruments which
14
are
दिन
doing. Yes, sir.
14 दिन 14 साल का वनवास टाइप ये जो फिगर आई है इसलिए मैंने
That
सोचा
is
कि इसके बारे में जरूर
the
जी.
spiritual side of you is making you say that. Okay,
यस यस.
because you are a well-read person. Okay, so here the lander instruments, whatever Chandra's surface thermophysical experiment. They will measure thermal conductivity and temperature of the lunar surface. Then there are instruments for lunar seismic activity. Like we know, no, at the earth, the earth means, okay, under the whatever the surface of the soil, below that what is happening, and some probe will be seeing the plasma density. So that these are all the experiments which are of very high interest to the scientific community. And rover is also having some of the instruments. So this
Okay.
rover will go, there is some called path, this algorithm. As per that, it will be going step by step. इतना दूर जाएगा, वहां रुकेगा, वहां थोड़ा experiments करेगा, और step जाएगा. That total that algorithm, that planning they will be doing. So all this will be done. This 14 days limitation is coming because, like we on Earth, we have got 12 hours, just average I am telling, 12 hours sunlight and 12 hours night, like that. So lunar night is equal to 14 Earth days. So after this time, again 14 days of this will be there. You will not be having 14 days night will be there. So at that time sunlight is not there. Then the whole instruments become cold. Our regular satellites also, low Earth orbit, if you take, every day 20 minutes they go through eclipse. And
Okay.
out of say 90 minutes, 20 to 25 minutes or 24 minutes, other
Oh,
66 or 56 minutes, so they will be going through sunlight period. So at that time again you can charge the batteries and all that. But here the 14 days of thermal management in the absence of solar power, and batteries are not so big to support for, because you are having a small lander which has to take all these instruments and landing fuel. So it is not possible to anywhere also they will not be doing. That is the reason after 14 days, this thermal environment is not maintained. But we try to do some tests and all, but that is a bonus. If it works after 14 days, that day we can clap. But as such, it is not a mission objective. But then,
oh,
yes, as you rightly said, worldwide there are missions, even Luna 25. If it has been working, it would have worked for 1 year. So, how do they do
oh,
it? So, that is where you have to do the heat generation by external means. That means not electrical means, neither solar power nor battery power. So, how you are going to do it? That is where the nuclear power comes into picture. So,
oh,
there is
oh,
something called RTG, radio thermoelectric generator. So, using
mm,
some radio isotopes, they are having we have to develop. Actually, I think just I saw some statement in some press that we are also in the process, and we are having Baba Atomic Research Center who are very advanced in this area. So I think a
okay.
collaborated way, if it is going on, fine. Otherwise, also it can be definitely done, because both the organizations are having a very good heritage. So that can be done. But the risks or the challenges associated with RTG development is the most important is the safety. Even during takeoff or any time, if it falls in an inhabited area or even on
Okay.
the loon. So how do you make it? You have to seal it in such a way. We know all the nuclear reactors also. Chernobyl
Correct.
is a classic example what happened. So
Correct.
we have to here, of course, this is not that kind of scale, but still within that, anything related to radioactivity, even X-ray also, people, when you go to a hospital, the people who work in X-ray laboratories are certified, they are trained for safety related certifications, and that has to be cleared by some regulatory authorities. So these related safety clearances have to be taken. For that, lot of tests have to be done to see its how it can withstand the impact loads, or an explosion happens, some temperatures may go up. At that time, how it withstands all those things, and the safety certification. Once they are done, definitely, I think our future missions, I think, will be having this capability. Otherwise,
Okay.
no point in repeating same thing.
Okay, so now coming to the final and the last question before we
Yes.
go to the audience, and that is the most important one जिसके लिए हमने आज ये जो प्रोग्राम किया है, और वो है मिलिट्री स्पिन ऑफ्स क्या होंगे इस ड्यूअल यूज टेक्नोलॉजी के, मिलिट्री
Yes.
स्पिन ऑफ्स क्या होंगे उसके ऊपर जरा इफ यू कुड थ्रो सम लाइट ऑन दैट,
Yeah.
then it will be I mean
Yes.
audience will get benefited.
Okay, sir. I think the biggest spin-off, all of you agree with me. The biggest
Yes.
spin-off is DRDO has converted a rocket man into a missile man.
Okay.
Dr. Abdul Kalam, who was a
Yeah.
original ISRO project first SLV project director, he has
Yeah.
people have forgotten that he was in rockets. He has become a missile man. I think what else spin-off you want more than that? So that is
Uh,
just this one. And I have also that integrated missile development program. There are so many technologies which are common and so many technologies which are required only for the missile. There is definitely a difference also, but whatever common base can be exploited. So that is one of the things. I'm first telling about general to defense and specific Chandrayaan developments also, which are having
Yeah,
potential that we can
correct,
see. And I
correct.
also had the opportunity, otherwise, maybe because as a DRDO assessment board, where their own senior engineers, for their promotion, they have to appear before assessment board. So in that, I was an external member. At that time, I could see what are all the developments that are happening across some 50 plus. Earlier it was 52. Now maybe some reorganization is going on. So all these DRDO laboratories, they develop so many instruments, so many equipment, so many systems which are required for the all the forces. So what is it that can be common, can definitely be seen, and I myself have seen at that time that there are so many. And actually, okay, some places there may be, because people know each other and they know that so and so is working in this area, they may be consulting, so that kind of things are there. But there are a lot of, and only difference is terrestrial. Actually, if we take terrestrial systems are more advanced in many things, because space, if you want to fly a system, we have to subject it to a lot of heritage is first thing we will look for. We generally don't want to change things unless it is having good heritage, and you have to go for space qualification, so which is a very very long drawn procedure. So but some of these space systems are much advanced compared to the area, especially in terms of lightweight materials. Okay. And specialized processes. Some of the processes, they may be required unique to space, but later people may realize that this can be used in the commercial field also, or in some aerospace, or in the field of even other defense equipment. And systems, one more difference is they are qualified for space environment, but military equipment, when you want to use, it is a totally different. If you want to use in Rajasthan, that environment is different. If you want to use it at some heights, Himalayas or somewhere else, that environment is different. If you want to use it Gujarat coast, because sea is there by the side, so that environment is different. So some of those re-engineering may have to be done, but some commonality can be found. And some of the things which by tailoring may be adaptable for this are, main thing is electro-optical systems. ISRO over time has developed our own whole space application center at Ahmedabad and laboratory for electro-optical systems. They have developed detectors onwards systems in conjunction with the SEL. They have done some very fundamental work or very elementary work onwards. It is done. Some detectors are developed. So on all the bands of electromagnetic spectrum, it could be optical, it could be laser, it could be okay, the IR. IR is of course maximum interest to the defense forces, because you want night viewing capabilities and all that. So definitely all types of optics, the front end optics, normal ground systems, when you make, you are not too much worried about weight and all that. But in space, because of various constraints, they are all made lightweighted, giving a high performance. So a lot of engineering, reflective optics, refractive optics, cathode optic, optical housings also. The structures have to withstand so many loads. So these are and all are offering very high degree of stability. These are all the things which are developed. So definitely some collaboration may be going on also, but definitely there will be more scope for that. And of course, front-end electronics, because in space we receive signals from 36,000 kilometers, 500 kilometers. The signal levels, whatever you are sensing, are very, very low. So definitely the front-end electronics is highly advanced. So those things also, to that kind of specifications may not be required, but those principles and all is another thing. And different types of mechanisms. Actually, ISRO has a enviable record among spacefaring nations. I don't know that, but they have done some 400 plus continuous, successively successful onboard deployments. That's what we tell. So there's a deployment mechanisms are there, and laser-based systems. So all these things can be definitely be there, and thermal management. So in a soldier sitting in a tank, definitely we want to air condition him if it is possible. Okay. So how to manage, how to throw out the heat that is generated inside, how to see that you are protected from external loads that are coming. So all these things also maybe together, if they work, there could be some improvements possible in indigenous developments. and propulsion, of course, is part of the missiles, and electronics systems also. Various things are there: power, communication, all, and inertial systems, sir. This is another very, very key area, especially gyros. It could be an optical based gyro, or it could be a mechanical gyro, because for getting the stability on various platforms, it could be naval platform, aerial platform, land based platform, gyros and all will provide a very good information with respect to the angular rates and all that. So that is another area where ISRO has done tremendously advanced work and totally indigenous developments without depending on any foreign resources. So that is another place. And navigations and guidance algorithms, then fault tolerant systems and the software. So it looks simpler, but real-time systems, when you have to develop the kind of algorithms that you have to develop, all those things, and of course project management. I have seen that because of the advantage of Dr. Abdul Kalam himself going there. Definitely, a lot of those project management techniques were not techniques actually. That project management discipline was implemented in a much higher way earlier. Also, definitely it was there, but it was strengthened by applying the principles of space systems related project management. And of course, this is another very important aspect, is the reliability. See, because we make systems for working up to 15 years and that kind of things, how do you make systems reliable? So there are host of analysis: failure mode analysis, fault tree analysis, derating, worst case circuit analysis, and reliability quantification. These and all also I have seen now that these are all being adopted in the developments. But definitely, always we can. I am not telling that from space we will. It's a two-way process. It can be both ways. And very specific developments for Chandryan, which they are done, I really don't know because I am not on the field. But some of the, like lander and rover itself, if you take lightweight structures, thermal mechanisms, whether any of those things can be used, and host of electro-optical. Because earlier we were doing detectors and all for reconnaissance or like the remote sensing missions. But here, a lot of laser-based systems are done exclusively for Chandrayaan purpose, and the hazard detection and avoidance altimeters, both radio frequency based as well as laser based. So altimeters, they are developed, and some position detection, then hazard avoidance. How do you,
Hmm.
like crater is there, you want to avoid and go. So the image processing algorithms, and I am certain that this
And this
image processing,
can these be used in the drones? I mean, this is something which
yeah, exactly, sir. I
is
was
very
telling
very
same thing.
handy.
Yeah,
Yeah.
definitely these kind of algorithms will be aerial platforms. Okay. Whatever aerial platforms are there, and now drones, of course, is there most happening, because when I, after retirement, I have been visiting several educational institutions across India. I have seen that
Mm.
every aerospace department, they have got a lot of big drones are there in every college. Okay.
Yeah.
So there is a lot of interest in this particular area. Youth are also very much attracted. So, but
Correct.
definitely there, for whether they can be used, we have to see, because here the specific, but it has to be re-engineered. But the principles of the development,
Yeah. Yeah.
the design, the design processes, so that is key.
Technology technology
Yes.
is there. Concept is there.
Yes.
That has to be
So how to adapt it to the requirements? This is
correct.
carbon altimeter I told, and image processing, then sensor fusion. You are having multiple sensors. System should not get confused which one to use. So how do you
Oh,
take data from different sources, multiple sources, and fuse that data? And how you take a informed decision without getting into some
this
adversity? That is also a
this
very advanced
this,
field of okay,
this is
this
going to be
optics.
this is going to be game changing in the sense that in the defense forces,
Yes,
there is something called OODA loop. Observe, orient, decide, and act. Right.
yes, sir.
So
Yes,
in all these, the sensors are now increasing as the time is going ahead. Technology is
yes,
increasing.
yes.
So this fusion aspect, I think, would be very handy for
Correct.
commanders to take decision
Yes,
or assisted decision,
yes,
I would say.
yes, yes, sir. You are a better judge, sir. Okay.
So I was just
Yes.
looking at
But
the
definitely, yeah, definitely, I think there is some scope. There is
yeah.
a lot of scope. Okay. And navigation, guidance, and control, these are required for all the missions, of course. And in Chandrayaan, it was much more, because the whole, that is the life. Yesterday, chairman, normally they don't name any particular discipline, but both the chairman as well as the project director as well as, and everybody mentioned about the team of navigation, guidance, and control, because of the various challenges that they are there, and
That
autonomy. Okay, in
it was the
Mars also. Yes,
it
sir.
was the lady who was responsible for this, no?
Sir,
There was
I will. Yeah, there are several people. Sir, in
no,
ISRO, everything is a teamwork. A lady might have led it. Okay,
no,
it is
yeah,
a teamwork.
I'm talking of the three people whom he brought on the stage. One of them was a lady.
Ah, okay.
So
She is the associate project director, sir. She is in
yeah,
the
yeah,
project management side. So they
okay.
will be because every day the P3 people were there was one is the project director, one is the
Hmm.
mission director who conducts the mission, and she is the
Yeah,
associate project director. Project
okay,
director and associate project director have to all these departments they have to interface day to day. Okay,
okay,
day to day or hour to hour or like he told 24 hours they have to be and they have to make the project move. So she is the one lady, Kalpana. Yeah, she is a
okay,
very
okay,
nice lady. Yes. So,
okay.
but navigation, guidance, and control, these are specialist fields, sir. These people
Okay.
are experts. They will be behind the scenes. Nobody will know that such a person is there. But behind the
Mhm.
scene, they will be spending similar hours or more because in their mind only algorithms will be running, mathematical formulations. So that is
Oh,
what they will be doing. And validation for all environments. So this is also another how to validate a system. You have developed a say MBT. We have developed how to validate that it does the function on the field. That is a very okay. You are having lot of okay like say semi-lac is there for air systems and all that. But there also
right.
I think some whether we can optimize or whether we can to enhance somewhere these things and all with a mutual dialogue is one possibility and some simulation tests and autonomy, mission planning, execution, real-time data analysis and display. Even displays, whatever you are seeing, there is a lot of engineering behind it. So all those real-time you are getting data, how to get it, how to display it in an interesting fashion. All those things are also very interesting things. Then oils, heals that onboard okay in loop simulation, hardware in loop simulation, 6 degrees of freedom. These are all testing related aspects. You have to plan the tests much from the day project starts. Even these also concurrent engineering, whatever they call, all these aspects will come into picture from that day itself. If you make a system which cannot be tested, there is no use, it will not fly. Okay, so all the things have to run hand in hand and the testing and the review of the results is also very critical. Sometimes people will find one small glitch which we may ignore, but the review committee will find and ask you, and when you dig it more you will find out that system has a lacuna which you have to correct. So I said all the possibilities from whatever little knowledge I have got, but actually now also it is happening based on the individual or somebody is some common people are there across or somebody by because they are interested in the field they would have read some publication and they would have contacted each other to help. But I feel what we are missing is a very formal platform to see
Absolutely.
constantly
That,
see.
that was my question. That was my
Yes,
question.
yes sir.
Before we go to the audience now, is
Yes,
that we have so much of scope for
yes sir.
usage of this technology which is there
Yeah.
as part of ISRO onto the various other systems,
Yes,
departments, including civil
yes,
departments, right?
sir.
Uh,
Yeah.
do we have anything like a central coordinating agency, or it is all left to the scientific advisor to the prime minister to do this kind of
Yeah.
a coordination, or you need a structure? Just quickly, 1 or 2
Yeah,
minutes.
yes, sir. Yeah, there
You
are
need.
some forums at the top level, there may be there, as you
Mhm,
told rightly about SARM, like
mhm,
that. But okay, they can do certain thing, but to go into the nitty gritty and all that, I think there
mhm.
could be scope. I really don't know. I think that is where forums like Strive or even now ISPA, Indian Space Association, is led by General Anil Bhatt.
Yeah,
So a
I'm aware
person
of.
who has the exposure to defense is
He,
heading the space private associations here. Now he will
yeah,
start getting more and more exposure here. So people like that or Strive or some people who have some common platform, maybe your think tank and deliberate on this with some of the other experts.
yeah,
Maybe you can
but
try to see how to bring little more formalism. Definitely, this government is putting a lot of efforts to for that Make in India initiative. Some things may be going on. I am also out of service for some time, so I also really don't know. But if it is there, good. If it is not there, whether something can be done, this can be. I was just thinking that if it is not there, whether Strive can do something, you can just think over. It's a food for thought for all, with my
yeah.
limited knowledge. Because without my knowledge, there may be several things happening. Okay.
Okay, last and the final before this is an answer in one word. इंडियन स्पेस इज रियली कमिंग ऑफ एज. इसकी
Yes.
काफी ग्रोथ हो रही है. तो हमारा
yes.
मार्केट शेयर जो ग्लोब में है बढ़ रहा है एवरी डे. What today is our market share, and how do you see it 5 years later or 10 years later in terms of percentages?
Yes, sir. As of now, the space economy as estimated, again, different Morgan Stanley will have some estimate, okay,
Yeah. I
or
mean,
some
your
other,
view,
yeah. But they
your knowledge.
expect around 350 billion dollars is what is estimated. That consists of launch vehicles, spacecraft, and more than anything, the applications. Okay,
Okay.
application segment is the major thing. Where in that Indian share is around 2% is what was the estimate
Okay.
by
Okay.
different survey agencies. Now the
Okay.
government has understood that by going private, we can enhance this share because there is a limit to what a government can do. We are focused, and ISRO should focus more on R&D. And whatever can be repeated. Right now, we are doing production also like launch vehicles and all.
Yeah,
Whatever
yeah, I
can be
understand.
produced, whatever can be produced has to be done outside. And another question also, the Prime Minister, Honorable Prime Minister, has asked during the inauguration of InSpace. If a boy in 10th standard, if he wants, has an idea, and if he wants to try in space, who am I to stop? So, and the space infrastructure, whatever is built up, because the deterrent for private to come in a large way is the huge investments required for some of the facilities. Like launchpad itself, you take. You have developed a rocket, you want to test Sriharikota, how a private company can do it, land acquisition, all those aspects. So, whatever is ISRO's property is not just for ISRO, it is for all the space industry in India. So, this is the principle with which they have done, and at a cost, of course, it will be made available, but the establishment cost they need not worry about. So at a nominal cost, so that every person cannot go there and knock the doors. So that is with those kind of things, the little reorganization is done. And in this new space policy, ISRO is assigned the task of research and development of advanced technologies, and New Space India Limited, they are to act as an exclusive public sector aggregator. Anybody wants to do anything, so it is an
Okay.
aggregator, it will be doing, and all the satellites of ISRO are transferred to NCL. Either they are transferred, some most are transferred, and some are in the process of transfer. So that commercial portion or the operational portion, ISRO need not worry and focus on R&D. And a new setup is started, that is InSpace, Indian National Space Authorization Center. So who will do the authorization as well as the regulation also? They will put both the things. They promote also. Normally it is promotion and authorization will not be in same hands, but here they have done because, and they brought a private sector leader to head this institution because they know the market. So otherwise, ISRO people are scientists and working in a specified way, but the market requirements and all can be better understood by a person who has been. So that's they are heading the in space. So it will act as a single window agency. Anybody wants to do anything in space, they can approach in space. They will guide further how to go about all those things. And if you have a rocket, if which you have developed, the required authorizations, and as you really, when the whole system grows up, idea is to enhance it by another at least 2% should go to 5-10 in a progressive
Okay.
way. Okay,
Okay.
so that is the objective. So in space will facilitate that, and making the India systems also, suppose some test is there, one facility is only one, ISRO wants to use it, a private sector person wants to use it at that time. So how to,
Okay.
that is called a manifest, and same launch vehicle also, launch manifest. So all those
Okay.
things, and they will develop the parameters how to go about, and it will be a very transparent system, and all they will develop. And they have already started. Actually, we have seen one recently, one private launch suborbital flight, it was there, but India's first suborbital flight has become successful. Okay, mission Arambh, they have told Arambh or Prarambh, yeah, that was
Thank
done
you.
back. Yes.
थैंक यू मिस्टर राव. आई थिंक इट वाज अ वंडरफुल डिस्कशन. और ये जो आपकी जो स्लाइड है जो आपने मुझे दी थी, ये बिल्कुल सही फिट बैठती है आज के डिस्कशन के लिए कि व्हाट वी नो इज अ ड्रॉप, व्हाट वी डोंट नो इज एन ओशन. आज
Sir,
हमारे
it is
हमारे
this Isaac Newton has said that, sir. The person
या
whom
वही.
at least I feel the greatest scientist on the earth, he
नो
has
नो
said this.
आई अंडरस्टैंड दैट इट्स देयर ऑन द स्लाइड.
Yes,
सो
yes.
हमारे व्यूअर्स आज समझ गए होंगे कि हमने एक बूंद का छोटा सा बूंद का हिस्सा जानने की कोशिश की है. अभी तो बूंद बूंद भर के ओशन बनना है। नॉलेज
Yes,
की
sir.
कमी, नॉलेज सीखने की कोई कमी नहीं है, नॉलेज हमारे चारों तरफ है, हमें बटोरने की जरूरत है। सर, वी विल मूव ऑन टू द क्वेश्चंस नाउ quickly because we have a limited time frame. The
Okay, sir.
first question, actually there are a lot of complimentary messages, so I will first
Dhanyawad,
give
sir.
but I'll first give the questions so that we finish off with the serious bit and then see some complimentary messages for you. The first question is by Samrat Ashok Patliputra. Why has India achieved cryogenic engine success but not made parallel strides in developing turbofan or turboprop engines for fighter jets, drones, helicopters, or tanks? If you know, do answer. If you don't know, we can always say that what is the challenges like between developing a cryogenic engine and developing a jet engine. What is the if you are aware
Sir,
of
I
the
lack the competence to answer this question on two fronts. I am
yeah,
primarily a spacecraft person. Even the
okay,
cryogenic engine belongs to a rocket. Okay.
okay,
And
okay.
the jet engines and all, they are totally different. And I am
Hmm.
more of an electronics person and project management.
So
Okay.
we leave.
Notwithstanding that, okay, I really don't know what all the definitely GTRE and all are there who are trying to develop engines and all. But I feel I would like to pass the question, sir. Okay.
Yeah, yeah. So I actually, Samrat, Mr. Rao does not have the expertise to, so he would not like to delve into a area which he is not fully aware
Yes.
of. There may be
Yes.
certain technical difficulties. That is why even China has not been able to develop an engine till today.
Yes.
Although China has gone to 20 trillion, 19 trillion economy, but it is still failing. So we need to have the answer from a jet man to
Yes.
get your answer correctly done. Okay, next question is from Mr. Bhatia. There is a renewed interest in moon post discovery of water by Chandrayaan 1. How come US, Russia, and China never thought of exploiting the south pole of moon with no mission in the recent past?
Okay, sir. Actually, originally the quest for the moon started because Soviet Union was very much advanced in the field of space. They did everything that you can think of in space first. Okay, during Cold War time. So Americans at that time they took up a challenge, and the then president, I think it must be Nixon, he has told that because American people were feeling let down, I mean down by whatever Russia is okay that Cold War time. So they
Yeah,
told that within 10 years we will put a man on the moon. That is the type of declaration they have made, and they achieved it. That is tremendously. I really don't know how they did it. I read a book also on that, Space, a novel by James Michener. So that's a extremely interesting book. People who are interested can read also, Space by James Michener. So at that time there was a lot of thrust, and they had to spend a real bomb for that. Okay, so and they were
mhm,
ready. Whole nation was support to ready to spend. But as the Cold War phase, and they have demonstrated, as you can see, even today, America is the only country who has spent not one or two or three, they have sent 14 astronauts or so to the moon. So, what is there left to explore? Because they have to get the grants from the Congress. So, it's not easy to get, anyway, you, all of you are very much into the, okay, you are a think tank. So, it's not easy to get grants for a purpose, for a mission where you cannot specify those objectives. You may tell exploration and all, but when the resources have to be distributed, so that's why it took backseat for certain time. But of late, all developing nations, including China and all, they took interest around that time. And once China started progressing in the space sector, I think America also thought that they cannot be, because China was having plans to set up some lunar research station along with Russia, all that kind of things. Then now definitely there is a renewed interest, and they are started Artemis mission, and this mission will be able to take they will go to South Pole. It will take humans again. Okay, India also there was a lot of coverage in the recent news that has signed the Artemis Accords like that. So they have, yes, definitely they have started. But when America does something, they try to do it in a totally different scale. So those missions are ongoing, sir, and it will be a manned mission also. Artemis, when they do it within 2025 or something, they had a target. Okay, small delays are always there in any high tech program,
Yeah, yeah,
but
I
they will be
agree.
doing it. And China is doing. China is doing. Russia also. That is the reason they attempted. Unfortunate that they have cut down in a little earlier phase, but they will overcome definitely. Yes.
This question might have the partial answer to the previous question. What was NASA's contribution to this mission? I am referring to collaboration now. That if one nation is sending, why not take the data, etc., from
Yeah.
that particular nation, and rather than wasting a duplicacy of money, the entire
Correct.
process. So, like we
Yes.
used the Chandrayaan one and economized our cost for Chandrayaan
Yes.
three. So,
Yes.
did
So
NASA
I
play a
will tell
role
you.
in Chandrayaan three?
Sorry, okay. NASA, actually, this mission, anyway, the ground support I have told, Australia will
Hmm.
be supporting, NASA, American stations will be supporting. So there are different stations across world who are supporting this. So that is one part. Apart from that, okay, well, good wishes is one part. But
Okay.
with the respect to NASA cooperation, when we talk about, there is another satellite which is getting assembled right now in ISRO. After going
Okay.
through, we developed a payload at our ISRO. We have sent
Hmm.
it to NASA. They
Hmm.
integrated with another payload. Okay, so the synthetic aperture radar. This is to see
Okay.
the environmental studies, and that is going to be one of the most complex spacecrafts. It will cost around 10,000 crores. And after NASA has tested it by integrating our payload, the whole payload has come back to India and now getting integrated with ISRO's platform systems. So the main bus, whatever we call platform, is ISRO's. And the whole thing will be launched by LVM. Okay. So our own vehicle will be GSLV will be lifting it. So this is a cooperation which is a very, very useful and very interesting to the scientific community and especially environmentalists and people who want to study the overall what is happening to the overall global scenario, scientific study. So for them, it will be a very useful mission. So wherever we can, we are collaborating, and it's a joint mission. Many of the missions, space shuttle and all, also if you take also, they are all joint missions. Russians used to lift American astronauts. Yes, sir.
Next question is a little mythological. Has our ancient astronomical knowledge been of any help in the space science? Because even Mr. Somnath had also referred to this in one of his speeches. Do
Yes.
you think it is, or it is just a talking point?
If Chairman ISRO has said, there must be something. But what he said was, I think there was a lot of work done, which everybody knows. India's contributions to the astronomy are well known and well recognized also, because the eclipse calculations and all, whatever they do by different methods, whatever we do, all those things will be coming almost to the accuracy of a few seconds. The calculations
Okay.
done by the old methods. So definitely it was there. Whether it is useful in the today's science and all, because science is a continuously evolving. So where who took what principle and all to establish and go, somebody should be a historian of science or something like that. We are only practitioners, and that too definitely there may be some bearings somewhere indirectly, but day to day, because now the science is so much advanced, we will be using the available platforms and available simulation, whatever they are available tools. Okay. So, but behind them, definitely people who ever found original formulations might have taken a lot of support from these things.
Since we have a audience which is from across the country, so it is not
Yes, sir.
only
Yes.
military people who are watching it. So there are a
Yes, sir.
lot of questions which are uh, related to our past stories, etc. This is one of
That's
them.
fine, sir.
Sir Moon,
See,
Sir Moon
sir, I
was
have learned
part.
one thing. If I don't know,
uh,
I will tell I don't know. Okay. So, but question is never. Our chairman, ex-chairman used to say, there is no question which is not this one.
Absolutely,
Every
because
question,
they
yes,
throw up some idea. They throw up some
yes, sir,
idea, right?
yes, sir. A
Even
question should
even if you,
always be welcome. Question is
it was
always
said, na,
welcome. Yes,
unintended question also
yes,
leads to some
yes.
benefits.
If
Sir
not
Moon was
me,
part.
somebody else may get stimulated by that, and it
Correct.
may start some process. That's
Sir
perfect, sir.
Moon was part and part of Earth and separated millions of years, so similar to Earth. Now, this statement, whether it is correct or not correct, if you are aware, you can tell. Otherwise,
Yeah, I think it's
uh,
correct only. It's correct.
correct.
As a part of universe formation, when you
Hmm.
take moon was is formed from the earth. Yes.
Okay. So the next question is from Kothari. What are the advantages of having our own space station? There's the ISS, and now the Chinese are launching the Tiangong 2. What resources, expertise does it take to make and maintain a space station?
Okay. See, space station, see, Gaganyaan mission we are hearing, it is not space station, but to take
Mm.
a man to space itself, in spite of this having been done, it is always a challenge because the safety is paramount. So Gaganyaan type mission itself, we are seeing how much time it is taking to develop because the human safety is involved. And when you want to establish a station, constantly you are keeping people there. So compared to the regular spacecrafts, the human engineering part of it and the medical part, space medicine, all these things also have to come. And normally, like a cargo aircraft versus a passenger aircraft, if you take passenger aircraft, has to be support the life. So that's why we have got pressurized cabins to have the human comfort. Small activity, if you go in Gaganyaan like mission and do just go and come, that whatever space suit is there, those kind of things may be sufficient. But if you want to do for a long time, the habitat, the whatever that environment for the people to live, that has to be created. And the waste disposal systems, okay, because human being every day we create so much of waste in different forms, so solid form, liquid form, gaseous. So all these things have to be handled for a very very long time till the next craft goes. And when the next craft goes with supplies or whatever it is, so then it has to go dock and then undock, bring back the people or bring back some used supplies, so or replenish the supplies. These are all the things which make a space station challenging. Then why when others are having, why we should have, that is everything we feel like that. In fact, an example of best is the GPS, the global positioning system. When it was the whole world is having the signals, but when we really wanted, all of you know what happened. That's how we
Yeah.
developed our own navic constellation, correct? So this is what can happen. So that is why assist a country which has the aspirations of becoming Vishwaguru. Okay, so science and technology is one area, and space exploration, okay, is a niche area within the science and technology. So definitely it will help if we have the adequate resources, and definitely our economy is growing, so our aspirations also will grow accordingly. Otherwise, the space things have started with the original vision of helping the common man, but we are expanding as our economy is growing. Yes.
This question we have already answered in our discussion, so we will not dwell more on it. Navigation, guidance, etc.
Yeah.
But just for the information that this was covered in detail by Mr. Rao during our question answer sessions, and this one, if you would like to attempt, request briefly cover possible economic benefits of the mission, the moon economy. I mean, he's trying to look at it
Yeah.
from a futuristic
Yeah, it
perspective.
is a highly futuristic. Okay.
Yeah.
Oh,
Yeah.
because so definitely moon economy, when they are telling, okay, tapping of the various resources which are available on the mineral resources, all of that tapping. And even if you want to go to further planetary travel, if you want to do, like Elon Musk has an ambition of setting up colonies on Mars and all that, Loon can act as a base station for that. So first go there, and from there you go away from the Earth's gravity. There it's only 1/6 of the gravity. So
Okay.
there will be. It's a very futuristic question, sir, as you have rightly said.
Hmm.
And yes, if you can exploit when Columbus started and went, okay, and discovered America, or when people came to India, Vasco da Gama and all, they were not knowing what they are going to, but they left with Kohinoor. So what is there? Definitely now some things are known, some unknown things will come out in further and further explorations. So that is why people want to set up research stations there, and we are also having a mission under study phase with Japanese. Okay, so that mission also is there. So this, I think, we will be there. We are going to study more, and as you study more and more, for some time it was not thought that water traces were there. With more studies, more aspects may come. So it is a science is a continuous process of
Yeah,
learning.
there was a hint given by the PM, Chanda Mama Dur ke, ab Chanda Mama Tour ke. So the tour might become one
Space
of
tourism,
the
yes, definitely, yeah,
one of the economy.
yeah,
Uh,
yes,
this captures today's discussion and the success of Chandrayaan 2. It's just a comment. A person turquoise waving, certainly a very, very proud moment for great nation Bharat. Many, many congratulations and best wishes to all the members of Project Chandrayaan and ISRO in general.
Certainly.
Thank you very much, sir. It was a wonderful discussion. We in a short while, in a short टाइम पीरियड आई थिंक वी हैव कवर्ड अ लॉट ऑफ ग्राउंड काफ़ी हमने कवर किया है इस डिस्कशन को हम अपना डिस्कशन यहीं पे समाप्त करते हैं एक बार फिर congratulating India, congratulating ISRO, congratulating the team Chandrayaan, and all those people who have worked for the last 5, 6, or 10 years in making Chandrayaan successful. We close this by requesting our viewers please like, subscribe, hit the hit the bell icon so that we can give you more such videos in future and encourage us by your wholehearted support. Thank you very much, Mr. Prakash Rao.
Sir, I just
Uh,
want to add one sentence only.
yeah, yeah,
नन्ना
sure.
मुन्ना राज हूँ, देश का सिपाही हूँ, बोलो मेरे संग जय हिंद जय हिंद जय हिंद सर.
I remember you said this in War College also, and General
Yes, sir.
Bipin Rawat got up and he appreciated your Josh at that point in time. So,
Yes, sir.
Mr. Rao is Nanna Munna Sipahi, but he has been working for the last 40 years as Nanna Munna Sipahi of ISRO. Very many thanks to him.
Yes, sir.
With
Sir,
that, we
thank
will close our discussion with this video.